Alright, continuing from here, we're going to just keep working through examples until you can start to get the hang of this. So now we have a trig function, sine of 5x dx. So for this one, your guess at u is going to be the 5x portion of that. Okay, so with u, we calculate du, which is just the derivative, which would be 5 dx. And then now we want to rewrite this, so that would be sine of u du. We want to check that. Sine of u is this. So that, and then we have 5 dx. Well, you only have dx, so what's extra over here is the 5, and to account for that, we're going to have a 1/5. So we'll pull a 1/5 out, so that way when those simplify, you don't have that extra. And we have, now we're ready to integrate. The antiderivative of sine of u is negative cosine of u plus a constant, and then of course you had this 1/5 out front times that. So we're just going to have negative 1/5 cosine, and if we replace u, 5x plus a constant. Okay. Alright, this next one, we're going to choose this to be our u. So u is going to be 4x to the third plus 1. Du we calculate by taking the derivative of that, which would be 12x squared dx. Okay. If we come back over here and rewrite this, this would be u to the 5th du, and we want to, let's check everything. That's u to the 5th. And then this is x squared dx. X squared dx. So the extra is this 12, and we want to accommodate for that, so we do it by 1 over that factor. So 1 over 12. So we pull that out, and now we're ready to integrate. So u to the n plus 1 over n plus 1 times this 1/12 that's just out front, and then we have plus a constant. So what's that, 1 over 72? U to the 6th plus a constant, and if we go ahead and replace u, we can plug in u right here and simplify. Alright, let's look at number 6. Just like we did before, we're going to rewrite so that we can have a better look at this before we determine u. So that's going to be x squared, and we're going to do 3x to the third plus 7 to the 1/3 power. So rewrite so then you can make an easy decision on u. U is going to be our 3x cubed plus 7. I didn't necessarily need parentheses there. So then when we calculate the derivative of u, that's just going to be non-x squared dx. And after we determine u and du, then we come over here, and if we write this as u to the 1/3 power du, so u to the 1/3 power, and then du is, you can see the x squared dx. X squared dx portion is there. The only thing that's not is the 9. So to account for that, we're going to pull out a 1/9. Now everything's there, everything is accounted for. So at that point, you're ready to integrate. The antiderivative is u to the n plus 1, which would be 4/3, and then that gives us, divide by n plus 1 is that. And then the 1/9 is brought down from being in front. And then, of course, we have plus a constant. So we'll take that and simplify it. Let's see. Looks like the 3 is reduced, so we'll have 1/12 u to the 4/3 plus a constant, and u is 3x cubed plus 7. Okay. Alright, this one looks a little bit different. So The one with the exponent is in the denominator, and that's okay. We're going to show you how that plays out in just a second. So u is going to be the 4 minus 3x squared minus 2x cubed. I think that's everything. Take the derivative. What's that? Negative 6x minus 6x squared dx. You can leave it like that, or you can, just because it's more than one term, I see there's a negative 6 in the front, so I can factor that out if I want it and have this version of it. It makes it a little bit easier to see in a minute the factored form, because our numerator looks like the factored form, and you'll get better at picking and choosing when's a good time to factor it or leave it as it is, because we know we're trying to make it match the original function. So I'm going to leave it like that and come over here, and this would be u to the 4th, and you just put 1 as a placeholder, the denominator, so rewrite u to the 4th, because we said that's what u is, so u to the 4th, and then we have du. Now what does du take care of? Du takes care of the x plus x squared dx, and you can see that's in our numerator, x squared plus x dx, and it makes it easier to see that this is what we have to account for. So a negative 1/6 is what we'll pull out front, and then now we'll just integrate. Bring this down, and then actually before we do that, let's make this even easier. We'll take a step and rewrite this as u to the negative 4 du. So bring the denominator up and write it with the negative exponent so that we can use the integration rules, and that's just u to the n plus 1 over n plus 1, so that's the negative, and then of course we have that negative 1/6 that's already out front that we need to bring down, plus a constant. So let's just simplify this up. Negative times a negative is a positive. Looks like it's going to be 1 over 18 in the bottom. This u to the negative 3 is going to come down to the bottom, so I'll go ahead and bring it to the bottom. So the u was 4 minus 3x squared minus 2x to the 3rd, and that's going to be to the positive 3rd power since I brought it down, and we have plus a constant. Okay, if it's easier for you to write it in the numerator and then take an extra step and bring it down, that's fine. At any point you can do that. Alright, so moving on, number 8, cosine square root of x, square root of x. Let's do, if you rewrite this, it's going to be cosine x to the 1/2 over x to the 1/2 power. In this case, we're going to let u is equal to x to the 1/2. Derivative of u is 1/2 x to the negative 1/2, or algebraically simplifying that, it's going to be 1 over 2 times the square root of x, or 1 over 2 x to the 1/2. Okay, both of these are equivalent forms. Dx. Put a dx, squeeze in a dx. So when we come over here and we rewrite this, this is going to be the integral of cosine of u du. So cosine of u, when u is 1/2, and then du is this, you have the 1 over x squared dx. So the 1 over x squared dx, you have that part, but what's the part you don't have is this 2, but it's in the denominator, so that's like 1/2. So if you don't have the 1/2, you need to multiply by the reciprocal, so you'll have 2. Just so you can see that a little better. The 1/2 part is the extra part because we have the x to the half dx. So the reciprocal 1/2 is 2/1, which is just the 2 that I pulled out here. So now we're ready to take the antiderivative of this, which is just carry down the 2. The integral of cosine of u is sine of u plus a constant. So then if we replace u, I'm going to have 2 sine square root of x plus a constant. Alright. I think we can, we'll stop right here and pick up with that on the next video.